Hi, and welcome in the first status report of Buzz. Today, I'm really excited to show you what this application is. Buzz is an instant messenger and telephony client for NAO. Currently, it uses Skype as a backend. Buzz can already use the text chat functionalities of Skype, where NAO is seeing the received message.
Alexa says hello. Alexa says this is a test. Welcome.
It can also accept incoming phone calls, but for the moment the audio is not working very well.
Alexa is calling you.
Let's see now how the program is implemented. We start with the main behavior. It's made in Choreograph and Python, and it packages all our resources, some binaries, a few scripts, and source files. The Choreograph behavior will execute a Python script that will declare itself as a broker to NAO key. The broker is then loading a NAO key module, the bus core, and this is also written in Python. During its initialization, the bus core is executing two binaries. Firstly, the Skype kit furnished by Skype will handle the communication with the Skype network. Secondly, a C++ program charged to provide the audio to the Skype kit, and this audio stream is itself provided by GStreamer. So, for the moment, it works like this. But in the near future, I will probably get rid of GStreamer and make another program that connects directly to NAO key sound modules and encode and decode itself the audio streams. And later on, this program will also handle the video stream. Coming back to the Choreograph behavior, it needs to communicate with the bus core. In one way, it opens an NAO proxy on the bus core module and invokes functions on it. On the other way, data flowing from the core to the behavior are mostly asynchronous data. So, to handle this situation, the core is writing in NAO memory values and the Choreograph behavior is subscribing on them. Eventually, the behavior also makes use of the text-to-speech functionalities as well as it blinks the LEDs when an event occurs. Of course, in the future, it will use more capabilities of the robot, such as adding motions during the conversation, for instance. Now that we have the big picture, we still need to configure the program. For the moment, it needs a Skype credential on the users. To do so, the user fills in its information on the widget of the application. They are then sent to the robot of the user through the infrastructure Aldebaran is providing using the XMPP protocol behind the scene. Last but not least, the application needs to be installed. And this is easily achieved thanks to the NAO store, and the behavior itself will be triggered by NAO's life. I add here a frontier showing you that most of the things are running on the robot itself. It has no dependency on your local computer. Let's see now in details how the Choreograph behavior is functioning. When the behavior is started, everything happens in this box. The first thing to do is to load the bus broker. This box will load this script, which itself loads the bus core module. The bus core is then launching the executables, one in this directory and this one. Then, when the bus core is ready, it will modify an NAO value, which is read by this box and then sent to this switch case, and when the OK value is read, it will jump to the login frame. The login frame is reading the credential from the preferences. The preferences are set by the widget of Buzz, which you can find in the My NAO section. The credentials are then sent to the bus core module, which will use them to authenticate on the Skype network. When the connection status is changing, the bus core is forwarding the information through an NAO memory value, which is then read by this box and sent to the switch case. But now let's see it in action. So now the bus core is loading. And now it's logging the user. And now the robot appears connected. Let's see now what happens when we send a message. When the bus core is receiving a message, it also forwards it in an A.R.l memory value, which is then read by this part of the program. So let's try to send a message now. Type my message and enter.
Alexa says hello.
And that's it.